Welcome to Thought Frontier.
Hey everyone, and welcome to another deep dive. This time, we're going to be tackling something truly mind-boggling. Black holes.
Yeah,
You've probably heard of them, of course,
of course.
but some recent discoveries suggest they're even weirder and more important to the story of the universe
Right.
than we ever imagined.
Yeah.
We've got 5 sources for this one, a mix of research articles and some science news pieces, and let me tell you, they reveal some pretty shocking stuff.
Yeah.
So we're going to try to untangle these findings and connect the dots between black holes, dark energy, and even the Big Bang itself.
Okay.
You ready for this?
Yeah, I'm ready. Let's go.
All right. So, for a long time, we thought we had black holes figured out. Einstein's theory of general relativity gave us a model, or a blueprint, if you will, that describes a spinning black hole.
Right. It's called the Kerr solution.
The Kerr solution. Okay.
And it was considered, pretty much rock solid.
Okay, so we had this blueprint, and everyone thought, okay, we got it. That explains it. But now this new research is suggesting it might be wrong.
Well, not entirely wrong, but incomplete. The Kerr solution assumed black holes were stable, like perfectly balanced spinning tops. But these new studies are finding that black holes might be a lot more, I guess you could say, wobbly than we thought. It's all about the energy building up inside the black hole, reaching unimaginable levels that could warp its structure.
So picture a star collapsing into a space smaller than the tip of your finger. Then multiply all the energy of that collapse 1,000,000 times over. And that's the kind of energy we're talking about here. It's causing these black holes to become unstable.
Exactly. The scientists are still trying to figure out what happens next in this process, but the possibilities are pretty wild. Imagine black holes exploding, or maybe even birthing new universes. We're talking about a potential paradigm shift in our understanding of the universe.
Yeah, this is blowing my mind a little bit. So we've got these unstable black holes just brimming with unimaginable energy, and that's where dark energy comes in. That mysterious force that's causing the universe to expand faster and faster.
Right, all that energy building up inside the black hole. Well, some scientists believe it's being converted into dark energy, right there inside the black hole.
So every time a black hole devours more matter, it's also pumping out dark energy and fueling the expansion of the universe.
Yeah, kind of blows your mind, right?
It's pretty amazing. Do we have any evidence to support this theory?
We do. The Dark Energy Spectroscopic Instrument, or DESO for short, is mapping millions of galaxies and has found something incredibly interesting. The density of dark energy seems to be increasing over time.
And that increase in dark energy matches up with the growth of black holes over billions of years.
Exactly. It's still early days for this research, but it's causing a lot of excitement in the world of cosmology. This connection between black holes and dark energy is huge. It could mean we've been completely wrong about how the universe works.
Okay, so we've got these unstable black holes pumping out dark energy, driving the expansion of the universe. That's a lot to take in. But how does this connect to the Big Bang? Wasn't that like the beginning of everything?
Well, that's where things get really interesting.
Okay.
Our sources actually point to a couple of different ways of looking at the Big Bang, and they both have some pretty mind-bending implications. The first is the standard model of cosmology, which says the Big Bang was followed by a period of super fast expansion called cosmic inflation.
Okay, so inflation smoothed everything out and set the stage for galaxies to form. Yeah, I remember learning about that.
Right.
What's the other view?
The second viewpoint challenges the idea that cosmic inflation is the whole story. Some scientists are proposing that the connection between black holes and dark energy points to a totally different picture of the early universe.
Okay.
One that involves a mirror universe where time runs backwards.
Hold on. A mirror universe where time runs backwards. That sounds like science fiction.
It's a radical concept, I know.
Yeah.
But stick with me.
Okay.
You see, one of the issues with the standard Big Bang model is that it requires a very specific set of conditions to create the universe we see today.
Right.
It's like winning the lottery 1,000,000 times in a row.
Yeah.
This mirror universe hypothesis, it kind of eliminates the need for such incredible luck.
Okay.
It suggests that the universe was born perfectly balanced with our universe and the mirror universe as two sides of the same coin.
Yeah.
Like, imagine a pond, and our universe is the reflection of another universe on the other side.
Okay, so two universes mirroring each other with time running in opposite directions. I can kind of see how that might solve some problems with the Big Bang, but what about dark matter? You know, that mysterious stuff that makes up a huge chunk of the universe.
Right.
Does this mirror universe idea explain that too?
It does. To understand this, we need to talk about neutrinos. You probably haven't heard much about them, but they're these tiny, almost ghostly particles that are constantly streaming through us. Billions of them pass through you every second. We know of 3 types of neutrinos, but there's a hypothetical 4th type called a right-handed neutrino.
Okay, so there might be this 4th type of neutrino. Why is that important?
Well, the mirror universe model predicts that these right-handed neutrinos would have been created in huge numbers during the Big Bang. And guess what? Their properties match up perfectly with what we know about dark matter.
So we might be seeing evidence of this mirror universe every time we see the effects of dark matter. That's pretty amazing. But how can we know for sure if this mirror universe idea is right? It seems so far out there.
That's the exciting part. This mirror universe idea actually makes a very specific prediction that we can test. It says that one of the 3 known types of neutrinos must be massless. If we can figure out the mass of all 3 types of neutrinos and one of them turns out to be massless, that would be a huge piece of evidence supporting this whole mirror universe idea.
So we just need to, weigh some neutrinos. How do you even do that?
It's not quite that simple,
Yeah.
but scientists are currently working on it using large-scale galaxy surveys. They're essentially using the entire universe as a giant laboratory to measure the properties of neutrinos and figure out their masses.
So we might actually get an answer to this.
Hopefully, yeah.
That's incredible to think that we could actually have evidence for a mirror universe. This is all so mind-boggling. So let me try to wrap my head around this.
Yeah.
We've learned that black holes are not what we thought they were. They're unstable. They might be the source of dark energy, and they could even point to the existence of a mirror universe. And this isn't just speculation. It's based on real observations and scientific research.
Exactly. What's so compelling about all of this is that we're right at the edge of our understanding of the universe. These new findings are forcing us to rethink some of our most basic assumptions about how everything works.
It's a lot to process, but it's also incredibly exciting. If even a small part of these ideas turn out to be true, it would completely revolutionize our understanding of cosmology. Okay, so we talked about this mirror universe where time runs backwards, pretty mind-blowing stuff. But let's imagine for a second that this idea is actually true. What would that mean for our understanding of, well, everything?
It really challenges our entire perception of reality, doesn't it?
Yeah.
If our universe is fundamentally connected to another universe where time flows in reverse,
Right.
it suggests that our everyday experience of time moving forward might be an illusion.
Whoa, okay, that's deep. So if these mirror universes are, connected, could there be some kind of interaction between them? Could we send a message to this other universe or even, travel there?
That's getting into science fiction territory. Yeah. But the math behind the mirror universe hypothesis, it doesn't completely rule it out. There could be some subtle interaction between the 2 universes.
Okay, so maybe we can't visit our time reverse twins just yet. But let's bring it back to our own universe for a moment. We talked about how black holes might be fueling the expansion of the universe. But could that expansion get out of control? Could those black holes eventually, I don't know, tear the universe apart?
That's a really interesting question. It leads to a concept called the Big Rip. If dark energy continues to increase in density, like those DSI observations suggest,
Right.
the expansion of the universe could accelerate to an extreme point where it overwhelms all other forces, even gravity.
So you're saying galaxies would be torn apart, stars would explode, and eventually even atoms would be shredded. That sounds pretty intense.
Yes, definitely a dramatic scenario.
Yeah.
But keep in mind, we're talking about cosmological timescales here.
Yeah.
Billions, even trillions
Right.
of years in the future. It's also possible that some other mechanism, something we haven't even thought of yet, could come into play and change things completely.
Yeah, it's like a cosmic plot twist.
Exactly.
I like it. You know, after this deep dive, it feels like we've just scratched the surface of what's really going on in the universe.
And that's the beauty of scientific exploration. Every new discovery opens up more questions and leads us further into the unknown.
So true. Okay, one last thought to leave you with. If black holes really are fueling the expansion of the universe, could they eventually lead to something entirely new, something beyond our current understanding of physics? Could a black hole be a doorway to another dimension, a bridge to a parallel universe, or even the birthplace of a brand new universe? It's incredible to think about all the possibilities.
I agree. Those are questions that will keep scientists and philosophers busy for a long, long time. And the answers, when they come, will undoubtedly reshape our understanding of the universe and our place within it.
Absolutely. Well, that's all the time we have for today. Thanks for joining us for another deep dive. And be sure to check back soon for more explorations of the biggest mysteries of the cosmos.